Right, for our atomic theory and bonding unit, lesson 3, we're going to be talking about today what does it mean to fill orbitals and how do you decide how this happens. So first things first, there are 3 rules that are going to govern how we fill orbitals. The first is the Aufbau principle. So this says that electrons enter the lowest energy sublevel first. The orbitals in a sublevel are also equal in energy, and then it uses this diagonal rule as a cheat sheet to kind of help you. So looking at this on the right here, basically the idea is that you start at the top. So the order in which you fill them starts with the 1s and then goes down to the 2s, then the 2p, and the 3s, and the 3p, the 4s, and the 3d, and the 4p, and the 5s, and so forth. So we're going to keep that in mind as we get started in a minute here. The second one says the Pauli exclusion principle says that no 2 electrons can have the same 4 quantum numbers. The 2 electrons in the same orbital must have opposite spins. It's kind of like the bottom line. So looking at this here, so this one right here is good. You'll see that you've got one up, one down in the same orbital. This is not okay because they're both going up, so it would have the same spin. This also would not be okay because they both are going down. So whenever we fill orbitals, we have to have one up, one down in each orbital. And the last one here is Hund's rule. So when filling orbitals of equal energy, one electron must occupy each orbital within a sublevel before you start pairing. Way to think about this is this bus seat rule. So if you think about if you have the opportunity to go on a bus somewhere, odds are you're probably going to want to sit in your own seat before you sit with anyone else. Okay, so kind of keep this idea in mind here. So looking at this one breaks the bus seat rule because you see how these two are paired up while this one is empty. Okay, so this is not good. This one here, they are all in their own kind of seat first or their own orbital, but the problem is they need to enter with parallel spins. So up, 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 or down, 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 but they all have to be going the same way. So this is also not good. And then this one's good to go. They're all in their own orbital. They're all facing the same way. So keep these ideas in mind. You don't want to break any of these when we fill any of our orbitals. All right, so looking at this one here. So when we put these electrons in orbitals, I'm going to be giving you this diagram here that you'll see. This guy's kind of like a cheat sheet. So it already is lined up for you that if you start from the bottom to the top, you're automatically going to follow Aufbau's principle with the 1s, then the 2s, and the 2p, then the 3s, and the 3p, and the 4s, and the 3d, and so forth, okay? So to practice this, we need to look at an element as an example. So if we look at calcium here, first thing you need to do is you need to look on the periodic table and decide, okay, if you have a certain element, you need to decide how many electrons does that element have. So if you look at the element on the periodic table, you are going to look for the atomic number for that element. So if you look at the atomic number for calcium on the periodic table, atomic number is 20. Because there's no charge here, okay, we have 20 electrons. So what does that mean? You're going to start at the bottom, you're going to start following those rules and filling the orbitals using arrows, okay? So we start at the 1s, which is lowest in energy. We put one up, one down. That's 2 electrons. Keep going until we hit 20. Okay, so one up, one down in the 2s is 4. Now, whenever you get to anything that has more than one orbital, I would follow the rules, specifically Hund's rule here, by putting 1 in each one first, the same spin, and then coming back and pairing them up. Okay, you may think it doesn't really matter here because yes, we do fill all of them, but in the case that you don't fill all of the orbitals, that's going to be good practice to get yourself into. So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Need to get to 20. So 11, 12, 13, 14, 15, 16, 17, 18. So I've got 2 left. They go in the 4s here. And that's done. Now, what if we had calcium plus 2? So this plus 2 means you need to take away 2 of the electrons that we have. So instead of 20, we now have 18. So in that case, you would get rid of the last 2 electrons we just put in here, which means that these 4s electrons would disappear. Okay. All right, so let's look at one more example here. So if we have Cr, okay, which is chromium on the periodic table, if you look for it, it's atomic number 24, okay? That means that we have 24 electrons to put in here because it does not have a charge, okay? So what we're going to do is we're going to start at the bottom again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Be careful, after the 4s, the next in energy is the 3d. Okay, so we come over here, and we have 4 electrons. So 1, 2, 3, 4. Here's again why I really recommend putting them singly in there first. So you remind yourself, okay, I have 4 electrons. It's just more left on here. Okay, 1 is in each orbital. They're all facing the same way. I always draw mine up first. If you want to put all of yours down, it doesn't matter as long as they're going the same way. Okay, but this last orbital should be empty. So we count them all up, we're looking at 24. All right, so that's a couple more practices I have here for you. So you got these you can try, and then we're going to be working with them and as well.